We are now kind of continuing some more information about sine graphs. We are looking at a sine graph right here from what we just were working on in our last video. So this graph is y equals 30 plus 25 sine of 18t. So that is what we just graphed right there. So some important vocab words. So the 30, that represents what is called the midline. And as the name suggests, it is the middle line of a sine function. So you can see we could draw in a green dotted line straight through the middle of this sine wave. That's what you call it, a wave. You could refer to it as a wave if you like. So that is the midline. So we'll put an A underneath of 30, and the A is going to stand. Well, the A is representing the midline. So the midline is representing the vertical shift of a sine and actually also cosine function or cosine function. And obviously it's the middle. So next important vocab word is known as amplitude. So the amplitude is the 25 right there, and we're going to use B in this video to represent that. Amplitude is the amount your graph is going up or down from the midline. So it would be this purple arrow right there or this purple arrow right here, and that's never going to change. It's always going up or down by that amount. So amplitude is our next vocab word. And that is the amount that the graph goes up or down from the midline. You can also sometimes might hear this referred to as a crest or a trough. And that could be, you could say that, well, those crests or troughs could be that the amplitude away from your midline. And that's a different way that some people refer to that same thing. So looking at the graph itself, one cycle is known as the period of a sine function or cosine function. So we would have basically, it's starting right here. So this is the period, one cycle for sine. And so that is basically what the period is. So the period is one cycle of a sine or cosine function. And so that's basically one full cycle, one cycle of sine or cosine function. And that is kind of horizontal distance. In this case of our first, we were talking about time. Sometimes it may not be time, although most of the time it is. So basically the time for one cycle to finish, or the length of one cycle. So now the number we haven't talked about yet is that 18. And so that 18 is either, you can refer to it as the angular speed, how many degrees per second you're going through, or the frequency, how many cycles you're finishing within one time period. So we'll say like C for our variable there, and then so we can finish our function up here. And those letters don't really mean anything right now, but we'll come maybe rearrange those. Just know that like you have them as what they are right there. So now we need to define some of those things. So we know we've already defined what angular speed is. So angular speed is degrees per second, and frequency is the number of cycles completed in a set amount. So it could be within a minute or within a second, or however you wanted to kind of think of frequency. So if you think about our example here, that 18 could represent 18 degrees per second, or it could also represent that if we know that the one cycle is 20 seconds, which we see it as our period, if we did 360 divided by 20 seconds for one cycle, we would know that 18 cycles finished within 360 degrees. So the last thing we want to write at the bottom here is that our frequency or angular speed, whichever you want to use, or angular speed, both of those can be represented by 360 degrees divided by the period. Because think about what we did here, 360 degrees divided by 20 degrees for one cycle on our first wheel, that got us 18 degrees per second, or 18 cycles in a full 360. 18 cycles completed, I guess. So now something to keep in mind that you can also kind of reverse this formula, that if you knew the period or how long your cycle was, you could do, or if you didn't know the period, you could do your frequency. 360 divided by 18 would also give you the other direction. So the last thing in this video that we'll talk about here is that you could also reverse this and do 360 degrees divided by the frequency or angular speed, and that equals the period. So whichever direction you're doing it, if you're working with degrees, you can do 360 divided by either one and get the one you are missing. And that's a quick overview of some important vocab for the graph of sine. And in tomorrow's classwork and lesson, we'll be looking at cosine as well. Thank you for watching.